here I'm going to do a simple example of greedy search, which is usually called best first greedy search. So here we have a diagram, we have the state diagram, and best first greedy search is basically using a priority queue based on age. So we have three types of search. So uniform cost search is based on G, the cost so far. The greedy search is based on H, the estimated cost in the future, and A search, which is the best one, which is based on the cost so far, the historical cost plus the future cost, G plus H. So here we're going to do the greedy search, which is basically only based on H, which is not accurate because H is estimated future cost. So we're going to keep track of a priority queue, and we're going to keep track of the expansion path. So at the beginning, you are going to enqueue S, and the value of S is 6. So remember, the priority is based on H now. So here, H is 6. So I'm just going to use that. And the first thing is to dequeue this. I'll expand this and add it to the expansion path. And you are going to enqueue the successor. So remember, there are three successors, G, A, and B. So you are going to enqueue them in the order. So it's kind of confusing whether you do A or G first, but I'll assume we do it according to alphabetical order. So A is 0, G is 0, and B is 6. The next, you are going to dequeue or expand A, and you are going to enqueue its successor. So successor of A is C and D. C is 4, D is 1. So let's move this B and putting D is 1, C is 4. So now you can you can dequeue G, and then you basically dequeue the goal, so you get the G already, so your search ends. And where is this G come from? G just directly come from this 9. So this is actually, you will not find the optimal path. The optimal path it finds is SG, which is not optimal at all. But the expansion path, in any case, is SAG.